Okay, good afternoon, all of you. Am I audible?
Yes.
Okay, without wasting time, we will start lecture. In last lecture, we have solved numericals on simply supported beam. Okay, how to draw shear force and bending moment diagram for simply supported beam. So today we will continue 2 or 3 numericals on simply supported beam, and then we will move towards cantilever beam. Okay, so first I will draw figure. You can also draw simultaneously, and then we will solve problem. Okay, I will draw figure. You can also draw. Okay, yesterday I think we have solved only one numerical, na? Right. Okay. So here simply supported beam is given, and on that beam throughout uniformly distributed load is applied. Throughout span uniformly distributed load is applied. For this we have to draw shear force and bending moment diagram. Okay, now I am expecting answers from your side. Okay. Two loads are acting simultaneously, one point load and one uniformly distributed load. And the location of point load is at 3 meter from A point. At 3 meter from A point, and remaining distance is 7 meter. So total span is 10 meter. Okay, so this is A and this is B. So here two reactions will be there. Reaction at A support and reaction at B support. So this is the question. Here one simply supported beam is given. On that beam, one point load act at 3 meter from A point, and one uniformly distributed load is applied throughout the span. So for this, first we have to calculate reactions. First, we have to calculate reactions. Okay. So whenever we will calculate reactions, at that time, there will be two parts. First part is related to summation of vertical forces, which is equal to 0. Whenever we will take summation of vertical forces, we will consider positive forces, upward forces positive and downward forces negative. So according to these sign conventions, we have to take addition of all vertical forces in this beam. So you tell me fast. Yes, RA plus RB minus 30
minus
minus 20
2
into 10, which is equal to 0. We have multiplied by here span. Okay, because of we have to convert this uniformly distributed load to point load. Okay, so RA plus RB, which is equal to, now we will shift this minus 30 minus 20 into 10 to right side. So minus 30 minus 20 into 10, that is 230, that is 230 kilonewton. So this is our equation 1. After that, second condition, that is we have to take movement at any point. Okay. So we will take summation movement at A, which is equal to 0. For this condition, sign conventions are clockwise movement we will consider positive and anti-clockwise movement we will consider negative. So we will start the movement taking from this B point. So this B point creates anti-clockwise movement towards this A support. So minus RB into perpendicular distance is 10 meter. Okay, after that we will move towards this uniformly distributed load. This uniformly distributed load creates clockwise movement. So plus, first we will convert 20 into 10 and after that it will act 10 by 2. Now this 20 kilonewton per meter load over, we will move towards this 30 kilonewton force. And this 30 kilonewton force creates clockwise movement. So plus 30 into perpendicular distance is 3, which is equal to 0. Now we will shift this minus RB into 10 to right side. So you make calculation 20 into 10 into 10 by 2 plus 30 into 3. How much?
1090.
1090. Okay. So RB, which is equal to 1090 divided by 10. So RB, which is equal to how much? 109 kilonewton. Now we will put this value of RB in equation 1 and we will calculate the value of RA. Okay. So we will put RB in equation 1. So equation 1 is RA plus RB, which is equal to 230. So RA plus RB is 109, which is equal to 230. So RA, which is equal to 230 minus 109. RA, which is equal to 121 kilonewton. So our reaction calculation part is over. We will write here values. RA is 121 and RB is 109. Now we will move towards next step, that is shear force calculations, SF calculations. Shear force calculation. So we will start from this A point. Okay. So we will use our trick. So for this, here RA is going upward. So plus 121. After that, we will move towards this minus. Okay. Before that, okay. Suppose this is C point. In between A to C, there is uniformly distributed load. So first we have to consider this and after that we will consider this 30 kilonewton. Okay, in previous problem, there is no any force in between A to C. That's why we have taken this point load. But in this case, there is force in between A to C. So first we have to consider this force. So this is downward force, 20 into, we have to multiply by here perpendicular distance because of convert to point load. So into 3, 20 into 3. And this calculation is before point load. Okay, this calculation is before point load. So you calculate and tell me how much? Minus or minus? Plus. Plus 121 minus 20 into 3, that is plus 61, right? Plus 61. So up to this C point, shear force calculations are over. Now we will calculate at C point considering this point load. So at the point C, this 30 kilonewton force going downward, so minus 30. So you calculate and tell me how much? Plus 31. After that, we will calculate at B, but before RB. Okay. So in between C to B, there is one uniformly distributed load will be there, and this load is going downward. So first we have to consider this load. So this is minus 20 into, now perpendicular distance, how much we will consider here? 7. Okay, good. So you calculate and tell me how much value is there. This is before RB. Okay, I will write here before RB. Yes, how much? Minus 109. Now we will calculate shear force at B considering this RB, and this RB force going upward. So plus 109. So minus 109 plus 109 is 0 kilonewton. Okay, so our calculations are over. Okay, according to this, now we will write shear force at A with how much shear force at B and shear force at C. So according to this table, you tell me shear force at A, which is equal to shear force at A, which is equal to 121 kilonewton. 121 kilonewton. After that, shear force at C, but before point load. Shear force at C, but before point load. Before point load, which is equal to how much? Plus 121 minus 20 into 3, which is equal to plus 61. Plus 61 kilonewton. After that, we will calculate shear force at C after point load. Shear force at C after point load. That means with considering point load. So up to this point load, value of shear force is plus 61. Okay. And at C point, 30 kilonewton force going downward. So minus 30, which is equal to plus 31 kilonewton. Okay. Now we will move towards this B point. Okay. But before RB, shear force at B, but before RB. But before RB. Before RB, which is equal to up to this C point, shear force is plus 31. Okay. And after that, in between C to B, uniformly distributed load, but downward. So minus 20 into 7. So you calculate and tell me shear force at B. It is minus 109 kilonewton. Now we will calculate last shear force at B, but after RB. That means considering reaction. After RB. So which is equal to minus 109, and at B point upward force is there plus 109, which is equal to 0 kilonewton. So these are the shear force calculations. Anybody having doubt in shear force calculation? Okay, then we will move towards next step, that is bending moment calculations. Third step is bending moment calculations. Bending moment calculations. Okay, so we will start bending moment calculation from this B point. Okay, from this B point. So bending moment at B, which is equal to how much?
0.
0. Okay, so bending moment at B, which is equal to 0 kilonewton meter. 0 kilonewton meter. After that, we will calculate next. Okay, so you observe in shear force calculation. One point is there, at which point shear force changes sign. You tell me where shear force changes sign. Shear force at B. Where? Yes, here. before RB. At B point before RB, shear force changes sign. So at this point, bending moment value is how much? Maximum bending moment value we will get. So we will find the location of maximum bending moment. Okay, so maximum bending moment location. So we will put here, okay, find location of maximum bending moment. तर हे कशावरून आपल्याला समजतंय, तर जिथे आपली शिअर फोर्सची व्हॅल्यू प्लस कडून मायनस कडे जाते म्हणजे त्या पॉइंटला काय होणार आहे, बेंडिंग मोमेंटची व्हॅल्यू मॅक्सिमम येणार आहे. तर या इक्वेशन मध्ये आपण फाइंड आउट करूया. सो इक्वेशन इज +31 minus 20 into x. Okay, we will consider this is x distance. Okay, 20 into x, which is equal to 0. So 31, which is equal to, we will shift this 20 into x to right side. So x, which is equal to 31 divided by 20. So which is equal to x, which is equal to how much? 1.55 meter. So at 1.55 meter, bending moment is, we will get maximum. Okay, now we will calculate. This is only location. Okay, so next step is maximum bending moment. So for this, I will draw figure of beam. Okay, so this is RB. The value of RB is how much? 109. Okay, 109. First I will draw here total figure, then I will erase. So this is our total figure. RA here 121, A point, and this is B point, and here something where C point is there. Okay, so 1.55 distance is from C point. Okay, this total span is 7 meter. So 7 minus 1.55 means how much span will be there? 5.45. बघ आपण हे मॅक्सिमम बेंडिंग मोमेंटचं जे लोकेशन फाइंड आउट केलेलं आहे ते लोकेशन कुठून फाइंड आउट केलंय? सी पॉइंट पासून फाइंड आउट केले आणि मुवमेंट आपण कुठल्या पॉइंट पासून घेतोय? बी पॉइंट पासून. टोटल स्पॅन जर आपला 7 मीटर आहे आणि सी कडून 1.55 मीटर डिस्टन्स वरती इथं कुठे तर तो पॉइंट आहे. मग काय करावं लागेल आपल्याला हे डिस्टन्स फाइंड आउट करण्यासाठी? 7 मायनस 1.55 म्हणजे आपल्याला आता ही फिगर कशी येणार आहे? पर्टिक्युलर पॉइंटची बेंडिंग मोमेंटची likewise only. So this is 5.45 meter. Okay, we have taken section here, and here uniformly distributed load is applied and intensity of uniformly distributed load is 20 kilonewton per meter. Okay, now we will calculate movement here. So whenever we will calculate movement, upward forces, that means it will create sagging nature, and downward means hogging nature, so negative. So this 109 creates sagging type of nature. So 109 into perpendicular distance is 5.45. After that we will move toward this 20 kilonewton per meter force. This pushes downward, that means hogging nature is there. So minus, first we will convert 20 into 5.45, and after that it will act at its CG 5.45 by 2. So now you calculate and tell me maximum bending moment, which is equal to how much? Yes, how much? 297 0.025 kilonewton meter. So this is the bending moment at maximum bending moment. Okay, now we will calculate bending moment at A. ओके, किती आन्सर आहे सांगा. 297 इज बरोबर, पण त्याच्या पुढचे सांगा. 0 to 5 मग 0 to 3 ती. अजून काही चुकते का तुमचं? 297 तिथपर्यंत बरोबर आहे. पॉइंट मध्ये तुमचं व्हेरिएशन येऊ शकतं, ते ऍक्सेप्टेबल आहे, पण 297 हे आलं पाहिजे. 297 is correct. Okay, now we will calculate bending moment at A point. Bending moment at A. Bending moment at A, which is before that we will calculate at C. So bending moment at C. Bending moment at C. Okay, for this we will consider span from this left side. Okay, we have to calculate bending moment at C point. So we will consider from this left side, because of here forces are, number of forces same, but span is less. So we will consider from this left side. So I will draw figure accordingly here. Okay, this is our C point. This is A. Here uniformly distributed load is applied 20 kilonewton per meter, and span in between A to C is 3 meter. Okay, so the value of RA is 121. This is pushes upward, that means sagging nature will be there. So plus 121 into perpendicular distance is 3 meter. Okay, then this 20 pushes downward, that means hogging nature will be there. So minus 20 into 3, and then it will act 3 by 2. So you calculate bending moment at C, which is equal to how much? 273 kilonewton meter. And last, bending moment at A. Bending moment at A, which is equal to, at A point force is there, but perpendicular distance is 0. That's why bending moment at A is 0 kilonewton meter. So these are the bending moment calculation. Now you observe bending moment at A is 0. At C 273. Maximum bending moment 297. And we have calculated bending moment at B. How much bending moment at B? 0. So here you have to cross verify. We calculated value of maximum bending moment, but in such this value is maximum or not? This is maximum, so our calculations are correct. Now you ask your question. Where? C. Okay. At C point, one point load will be there, but this point load is acting at that particular point. So perpendicular distance is, we are calculating moment at C. You clear here? Bending moment at C. We have considered this span from this left side. Okay, this is our A point, and we are calculating moment at this point. Okay, this is 121 kilonewton. First we will consider this only force. Okay, this 121. 121 into perpendicular distance is 3. Okay, got it? This load is over. Now we will draw this uniformly distributed load in between E to C. This uniformly distributed load 20. Okay, and this pushes downward, that means hogging type of nature will be there. So minus. First we will convert UDL to point load. So 20 into 3, and it will act at 3 by 2. Now your doubt is, at C point, one point load is applied, right? And the intensity of point load is 30 kilonewton. Okay, I will consider here minus 30. Now you tell me perpendicular distance for this C point. Yes, that's why I have not considered. 30 into 3, 0, that is 0. So if we not consider, then we'll get same answer. If you have to consider, no problem, you again, you have to consider this. Got it? Now anybody having doubt? So these are the shear force and bending moment calculations. Last step is remaining, that is shear force diagram and bending moment diagram. So we will draw fast. Okay. First, I will draw here original figure. So originally This is simply supported beam. Okay. On that beam, one point load is applied and one uniformly distributed load. I will extend all these lines, so we will get, or we will able to draw appropriate and proportionate shear force and bending moment diagram. Okay, so this is AB beam, simply supported beam AB. Here one point load is applied, so we will consider this is C point and intensity is 30 kilonewton. And on whole span, uniformly distributed load is applied, intensity is 20 kilonewton per meter. Okay, so span for AC is 3 meter and span for BC is 7 meter. Now we will draw first shear force diagram. So I request all of you, please tell me values fast. Shear force at A, which is equal to how much? Shear force at A, 121. So positive value, that means above baseline. So 121. After that, shear force at C. But before this point load, before this point load, so value is how much?
Plus 61.
Plus 61. Okay, I have drawn here inclined line. Why I have drawn inclined line? Anyone please? UDL.
Value.
Okay, UDL. That's why. After this point load, shear force is how much? 31. Okay, so plus 31. That means it will come here up to this point. After that, shear force at B, but before RB, that is minus 109. So now our shear force diagram will be go below baseline, minus 109, and shear force at B is 109. So we will close this figure. Okay, so this is the shear force diagram. Here this whole plus and this is minus. Okay, here 109, here 0, this is B point, this is A point. Here value is 121, here 61, here 31. And now you observe here value of shear force is 0. That means at this point the value of bending moment is maximum. So we will mark as a this suppose D point. Okay, this D point. Now we will draw bending moment diagram. I will extend this line also because of at this point we got maximum bending moment value. Okay, so first I will draw baseline here. You tell me the value of bending moment, all values are positive. Yes, so our diagram is above baseline. Okay, so you tell me bending moment at B, which is equal to how much? Yes, bending moment at B is 0. After that, where shear force is 0, at that point bending moment is maximum, and the value of maximum bending moment is 297. 297.025. After that, we have calculated bending moment at C. So bending moment at C, which is equal to 273. So below this 273, and bending moment at A is 0. Now we will join this. Whole diagram is in positive. So this is the bending moment diagram, and this nature is parabolic because of throughout span uniformly distributed load is applied, and this is the shear force diagram. Please write down fast. Okay, if your writing is over on this first slide, shall I move towards second slide? Let me know after your writing is over. So I will take next example. Okay, shall I take next example? Okay, I will draw figures simultaneously. You can also draw. So this is example in that all types of forces applied. So pay attention on this example. So this is simply supported beam and one moment couple, one point load and one uniformly distributed load is applied here. This is A point. At B point, one moment couple is applied. This is B point, and intensity of moment couple is 20 kilonewton meter. After that, C point is there, and in between C to D, uniformly distributed load is applied, and intensity of uniformly distributed load is 30 kilonewton per meter. Okay. After that, one point load is applied, and intensity of point load is 50 kilonewton. 50 kilonewton. So this is C point, this is D, this is E, and last one is F point. Now I will write values of span. Here 2 meter, this is 1 meter, this is 3 meter, and D to E is 2 meter, and E to F is 1 meter. So here RA reaction will be there, and here RF reaction will be there. Okay. Now we will solve. Same, first step is reaction calculations. Reaction calculation. So in that, first is first summation FV, which is equal to 0, upward forces positive, downward forces negative. So RA and RF going upward. So RA plus RF, RA plus RF. Now this 20 kilonewton meter we will consider in vertical forces or not? Not, because of this is moment couple. Okay, after that next force, that is 30 kilonewton per meter, uniformly distributed, going downward. So minus 30 into 3. After that this 50 going downward. So minus 50, which is equal to 0. So you shift this minus 13 to 3, minus 50 to right side and calculate value and tell me RA plus RF, which is equal to how much? RA plus RF, which is equal to 13 to 3 is 90 plus 50, that is 140. So RA plus RF, which is equal to 240, sorry, 140, no?
40, ma'am.
140 kilonewton. Okay, this is our equation 1. Now we will apply second condition, B condition, summation movement at A, which is equal to 0. Okay, so this RF creates anti-clockwise. Clockwise movement we will consider positive, anti-clockwise movement we will consider negative. So RF creates anti-clockwise. So minus RF into perpendicular distance is how much? 2 plus 3, 1, 3, 3, 9. Okay, RF into 9. After that, we will consider this 50 kilonewton force. This 50 creates clockwise. So 50 into, we are taking movement at A point.
Eight.
So 1 or 8? 8.
8.
Oh, this 1 reduces and remaining is 3 plus 2 plus 1 plus 2. After that, we will move towards this 30 kilonewton force. So this is again creates clockwise. So plus, first we will convert into point load, 30 into 3. Now you tell me at which distance this is at. Okay, please pay attention here. Okay, we are calculating movement at A point. So it will act at its CG, but we have to consider this 2 plus 1 distance again. Why? Because of we are calculating movement at A. बघ आपण A point ला movement काढतोय. ठीक आहे? हे 33/2 म्हणजे त्याच्या पर्टिक्युलर स्पॅनच्या हाफला झालं. पण movement कुठे काढतोय आपण A पॉइंटला. त्यामुळे आपल्याला हे C पासून इथपर्यंत डिस्टन्स कन्सिडर करावं लागेल. सो +3. Okay. After that, now this 20 kilonewton meter for movement couple we will consider or not? Consider, because this is movement. So, and this is anti-clockwise. So minus 20, which is equal to 0. Now we will shift this RA into 9 to right side. You make these calculations. And you tell me value fast. 50 into 8, that is 400. Okay, 30 into 3, 90 into 4.5 and minus 20. Yes, calculate. 8, 0.
805.
Okay, 805. So RF, which is equal to 805 divided by 9. So therefore RF, which is equal to 89. Yes, divided by 9. No, you have done some mistake. You check this value, 805 is correct or incorrect.
Seven, 8, 5.
785, na?
Yes.
700.
785. Okay. 785 divided by 9.
87.22.
Yes. Yes, correct answer. 87.22 kilonewton. So this is the reaction at F point. Now we will put this value in equation 1 and we will calculate reaction at A point. Okay. So you calculate and tell me RA, which is equal to how much?
52.78.
Yes, I will write here. Put RF in equation 1. In equation 1. So RA plus RF RA plus RF, which is equal to 140. So RA plus 87.22, which is equal to 140. RA, which is equal to 140 minus 87.22. So automatically you will get answer RA, which is equal to 52.78 kilonewton. Okay, so these are the reactions at A and reaction at F. Next step is shear force calculations. Shear force calculation. So I will write here values. RA, which is equal to 52.78 and RF, which is equal to 87.22. Okay. So we will write here shear force at A according to our sign convention. So RA, this force is going upward. So plus 52.78. After that, we will move towards at this B point. At B point. Now you tell me at B point how much load will be there? किती असेल वो B point ला load?
0.
आहे का? नाही आहे. 0 असणार आहे. So plus 0. So answer is same. 52.78. Now we will move towards C point. Okay, in between B to C there is no force. So C. At C, how much force is there? At C, at C. Again 0 because of there is no force. So 0. Value is 52.78. 52.78. Now we will calculate at D point. So here uniformly distributed load going downward. So minus 30 into 3. So you calculate and tell me how much.
Minus 37.22.
Yes, minus 37.22. Now we will move towards this E point. At E point, 50 kilonewton going downward. So minus 50. Minus 87.22. And at F, upward force is there, 87.22. So 0. That means our calculations are correct. Now we will write. Okay, you have to check here. At end point, shear force value is 0. If you got 1, 2, 3, 4 something in simply supported beam, at that time your answer is wrong. For simply supported beam, we have started calculation from A side, and at F the value of shear force is always 0. Okay, so now we will write values. Shear force at A, which is equal to shear force at A, which is equal to, here only one force is there, plus 52.78 kilonewton. After that, in between A to B, there is no force. So we will calculate at B point directly. So shear force at B. Okay. So you observe here at B, movement couple is there. So vertical force is not. So plus 52.78 plus 0, which is equal to 52.78 kilonewton. After that, in between B to C, there is no force. So shear force at C, we will calculate at C. But you observe here, at C, no force. After C, force is there. So 52.78 plus 0, which is equal to 52.78 kilonewton. Now you observe here, in between C to D, force is there. So we will calculate at D. So shear force at D. Up to this C point, value is 52.78. and at in between C to D there is force and downward. So minus 30 into 3, which is equal to minus 37.22 kilonewton. After that we will calculate at E. The shear force at E, which is equal to up to E point minus 37.22, and at E point downward 50. So minus 50, which is equal to minus 87.22 kilonewton, and shear force at F, which is equal to minus 87.22, and here upward force is there, so plus 87.22, which is equal to 0 kilonewton. Now you tell me at which point bending moment is maximum, or at which point shear force will change its sign.
D.
Where? D. Okay. You observe here. At C point, shear force is positive, and at D point, shear force is negative. That means it indicates at this point the value of bending moment is maximum. So we will find location. Okay. Let us find zero shear force location. Zero shear force location. That means at which point or where shear force is 0, we will find this location. So minus 52.78, sorry, plus 52.78, and instead of this 30 into 3, we will consider x. We will calculate from this C side. Okay, so plus minus 30 into x, which is equal to 0. We will take here section, and this is called as x. Okay. We will shift this to right side. So 52.78, which is equal to 30x. So x, which is equal to 52.78 divided by 2. Sorry, 30. Yeah? 1.75 meter, but from C point. Okay, from C point. And if I have to find out from this D point, so how to calculate? X, which is equal to how much at D point? Okay, total span for this C to D is 3 meter. And C to X is 1.75, and we have to find out this remaining distance, this remaining. So this remaining is 3 minus 1.75, which is equal to
1.25.
1.25 meter from which point? D point. Okay, from D point. So at this point, shear force is 0, and same here, bending moment is maximum. Okay, now we will calculate bending moment calculations. We will do here bending moment calculations. Before that, I will draw figure here so you will understand easily. Whole diagram I will draw here. First, you tell me which loads are acting here. Yes, first. This is suppose our A point, and this is F point. I think at B point, moment couple is there. Intensity is 20 kilonewton meter. After that, in between B to C, there is no force. Na? So here, C to D, UDL is applied. Intensity is 30 kilonewton per meter. Okay, this is 3 meter. This is 1. This is 2. Okay. After that, here one point load is applied. Intensity of point load is 50 kilonewton. I think here 2 meter and here 1 meter. Right now? Okay. Now we will calculate bending moment values. So bending moment calculations. So we will start from this F point. Okay, I will write here value of RA and RF. RA is 87, 52 point something. No? Yes,
52.78.
52.78, and RF is
87.22.
87.22. Okay, we will start from this F point. So now you tell me bending moment at F, which is equal to how much? 0, because of force is there, but perpendicular distance is 0. After that, we will move towards at this E point. At this E point. Okay. So next point is bending moment at E, which is equal to. I will draw figure here for this E point. Here 87.22 force is applied and this distance is 1. Okay, and this is our E point. So this pushes upward. That means sagging type of nature will be there. Okay, so plus 87.22 into 1, which is equal to 87.22 kilonewton meter. After that, we will calculate bending moment at D. Bending moment at D. Bending moment at D. So for this span is likewise here 87.22. This is 50 kilonewton force is applied. This distance is 1 meter. This is D point. Okay. And this is 2. Now you tell me how we will calculate movement? Plus or minus? Plus, because of this pushes upward, that means sagging type of nature will be there. बघा एक लक्षात ठेवायचं की आपल्याला जर साइन कन्व्हेन्शनचा घोटाळा होत असेल, हात वर करतोय तर काय येते पॉझिटिव्ह एनर्जी, म्हणजे अपवर्ड फोर्सेस काय असतात नेहमी पॉझिटिव्ह आणि डाउनवर्ड फोर्सेस निगेटिव्ह. ओके, सो दिस plus, so plus 87.22 into perpendicular distance is 3 meter. Okay, now this 50 kilonewton, this pushes downward, that means sagging type of nature will be there. So minus 50 into 2. So you calculate and tell me how much? 161.66 kilonewton meter. After that, we will calculate maximum bending moment, because of our maximum bending moment location is in between C to D. Okay, so next step is we will calculate maximum bending moment. Maximum bending moment. Okay, so from a right side, so this is 87.22. okay, here 50 kilonewton force is applied. This distance is 1 meter. Okay, after that this is D point. Okay, am I right? This is D point, this is 2 meter, and suppose here our location. So from this D point, okay, from this D point our X distance is 1.25 meter. So we will write here 1.25. Now we will calculate movement. Yes, fast. Plus or minus? Plus 87.22 into 4.25. Then next, this 50 kilonewton force is there, na? So minus 50 into 3.25, and after that this is UDL. Intensity is I think 30, na? 30, yes. Minus 30 into 1.25 into, it will act 1.25 by 2. So you calculate and tell me maximum bending moment which is equal to. Calculate correct answer. Huh? Where is your calculator? Yes, calculate. 184.74. Okay, good, correct answer. 184.74 kilonewton meter. Simultaneously you observe. Already we have calculated 2-3 values, and this maximum bending value is greater than of these two values or not? Yes.
Yes.
That means our calculations are correct. Then next, we will calculate bending moment at B point. Because of here C point, no load is there. Okay, so bending moment at B. We will start from this left side. Because of here number of forces are there. So we will calculate from this left side. So bending moment at B. Okay, before that we will calculate C. Bending moment at C. Bending moment at C. Bending moment at C. So we will calculate from this left side. Huh? So I will draw figure here. Here 52.78. Here movement couple is there 20. And this is our C point. This is 1 meter distance and this is 2 meter. Huh. Tell me fast. 52.3.
78 into 3.
Okay. Then minus, because of this is pushes here beam to downward. Okay. So minus 20, which is equal to, calculate and tell me bending moment at C, which is equal to 1.34 kilonewton meter. After that, we will calculate at B. So bending moment at B. Bending moment at B, but before couple. Okay, but before couple, we will calculate. Before couple. So which is equal to? Which is equal to? Okay, I will draw figure here. So before couple, that means only one force is there, 52.78, and this is B point, and this is 2 meter span is there. So 52.78 into 2, which is equal to 105.6. Okay, 56 kilonewton meter. Now we will calculate at B, but after couple. Bending moment at B, but after couple. After couple. Which is equal to, okay, I will draw figure here. This is 52.78, and here this is couple is there 20. Okay, this couple is pushes downward here. Okay, so this is perpendicular distance is 2 meters. So plus 52.78 into 2 and minus 20, which is equal to how much? 85.56. 85.56 kilonewton meter. Last point is remaining. Bending moment at A. How much bending moment at A? Definitely 0, because of
0.
force is there, but perpendicular distance is 0. So 0 kilonewton meter. Now we will draw shear force and bending moment diagram. First I will draw original beam. Okay, this is 2 meter, this is 1, this is 3, this is 2 meter, and this is 1 meter. I will extend all lines first and then we will draw. Okay, shear force values are, I think, positive and negative. Both values are there, na? So that means diagram is above and below baseline. So we will draw. Yes, now you tell me shear force at A, which is equal to how much?
52.7.
52.78. Okay, after that, I think at B, shear force is same because of there is no any force. So we will draw constant figure. Okay, up to C point because of there is no load. Okay, now you tell me shear force at D, how much? Minus 37.22. That means it will go below baseline. Yes, inclined enough because of here uniformly distributed load is there. Minus 37.22 at D point. Okay. From D to E, there is no force. That means constant line will be there. Constant horizontal line will be there. So I will draw here from this D to E constant line. Now, shear force at E, which is equal to minus 87.22. So below here. Okay. After that, E to F, no force. So it will again constant. And at F, shear force is 0. So here diagram will be closed. So this is the shear force diagram. We will write values here. So here RA is 52.78 and 87.22. This is A point and this is F point. Okay, here value is 52.78. Here again same 52.78. You also write here. Huh? I am having no space, that's why I have not written here. 52.78 here also 52.78. Okay, you observe here at this point shear force is 0. So this force is this point is called as contra shear.
Contra shear.
Contra shear. Where shear force is 0, this point is called as point of contra shear. And at point of contra shear, the value of bending moment is maximum. Okay. Now, so after that, shear force at D is minus. No, we will not write minus because of already diagram is below baseline. So 37.22. Here again same 37.22. Here 87.22. Here 87.22 and here 0. So this is minus and this is plus. This is our shear force diagram. Now we will draw bending moment diagram. I think all values are positive for bending moment diagram, right now?
Yes.
So we will draw baseline below and then we will mark up first values and then we will draw figure. So you tell me fast. Okay, now this point we have to extend because of at this point bending moment is maximum. So I will extend this line. Yes. Now we will mark first point and then we'll connect. Bending moment at F point 0. Okay, bending moment at F 0. After that, bending moment at E point. You see here
87.22.
Suppose here point is there 87.22. After that, bending moment at D
161.66.
161.66. After that, maximum value 184. Okay, so here 184.74. After that, bending moment at C. Bending moment at C.
0.34.
138. That means below this 161 na here. So below this 138. Above 87. Yes. 138.34. And bending moment at B. Bending moment at B.
0.56.
There are 2 points, before couple and after couple. Okay. So 105. Here 105. Okay, we will mark this 87. This 87 point below. This is 87 na? Here we will mark here 87. 87.22. Ah, yes. At B point, value is 105 na? 105. And after that 105.56. And after that 85. So near about this 87. Okay, so here. And this value is 85.56. 85.56. And at A point, bending moment is 0. Okay. Now, where parabolic nature will be there? In between which portion? In between C to D. So, from this C to D, from this C to D, nature is parabolic. And after that, we have to draw straight or inclined lines. So, we'll start from this point here. Okay. इथं बी पॉइंटला एकाच पॉइंट ह्याच्यात 2 व्हॅल्यू कसं आल्या तो कोण सांगतो बी पॉइंटला बेंडिंग मोमेंटच्या व्हॅल्यू आफ्टर आणि बिफोर आहे त्याच्यामुळे त्या 2 व्हॅल्यू आलेल्या आहेत सी ला एकच व्हॅल्यू आहे इथं आपण डबल काढली इथं नाही आलं पाहिजे तो पॉइंट this is B point from this here value is at C point 138.34 whole diagram is in positive this is bending moment diagram okay write fast so we'll take next example
हॅलो मॅम
yes
मॅम 1 मिनिट डायग्राम शो करता का तुम्ही
yes
पॉइंट बी ला बिफोर बेंडिंग 105.35 मग कर्व वरून का घेतलाय आफ्टर वरून घ्यायला पाहिजे ना
आफ्टर वरून म्हणजे
बिफोर बेंडिंग किती 10.105.6
हा इथं पॉइंट आला तो 105 पॉइंट समथिंग इथं पॉइंट आलाय तो इथं पॉइंट येतो मी दुसऱ्या कलरनी मार्क करते म्हणजे तुमच्या लक्षात येईल हे बघा इथं पॉइंट येतो इथं पासून ते सी पर्यंत इथं पासून ते सी पर्यंत इन्क्लाइंड लाईन आहे आपली आणि सी पासून पुढे कर्व आहे
तो नाही म्हणत मॅम 105.36 म्हणजे पॉइंट बी वरून सी वर जातोय का नाही त्यात पॉइंट 85.56 पासून जायला पाहिजे असं म्हणायचं मला
नाही 85 पासून कसं जाणार बघा बिफोर तुमच्या आता ए पासून आपण स्टार्ट केलं समजा तर याला 0 आहे बरोबर आहे मग बी ला बिफोर कपल किती व्हॅल्यू आहे इथे तुमची 85 आहे बरोबर आहे आणि तो इकडे चाललाय वर 105 त्याची पुढे व्हॅल्यू जाते आफ्टर कपल मग इथे 105 आला आणि तिथून पुढे जाणार तो 85 मधून नसतो जात तो तसा
बट मॅम ती व्हॅल्यू आफ्टर कपलचीच आहे ना 85 मग ती नंतर येणार आणि त्याच्या आधी ते 105 येणार ना
कुठली व्हॅल्यू म्हणताय तुम्ही
जे आफ्टर कपल आहे ते 85.56 आहे
आफ्टर कपल आहे ते
56
85.56 आहे
आणि बिफोर आहे ती 105 मग ती आधी व्हॅल्यू येणार ना मग तो कनेक्ट करायचा ना आधी पॉइंट
तुमच्या म्हणण्यानुसार आपण ड्रॉ करू मग लक्षात येईल तुमच्या
म्हणजे 0 to 105 आधी कनेक्ट करायचं देन 85 to 130
इथं ए ला 0 आहे बरोबर आहे आता बेंडिंग मोमेंट ऍट बी बिफोर कपल किती व्हॅल्यू आहे बिफोर कपल 105 ओके सपोज आपण इथं 105 मार्क केलं इथं आय विल यूज डिफरंट कलर सो यू विल एबल टू सी हिअर 105 बरोबर आहे तुमच्या म्हणण्यानुसार हे 105 आलं आणि 105 मधून इथं डाऊनवर्ड येते परत बरोबर आहे का इथं 85.56 हे कनेक्शन इथं असेल आणि इथून कनेक्शन इथं जाईल आलं का आता लक्षात
आहे
मयूर आता तुमचा डाऊट क्लिअर झाला
येस मॅम
हा येस नाव यू ड्रॉ काय म्हणताय केतन Okay, those students are attending online lecture. I request please take screenshot and after that you complete your notebook. Okay, so we will take next example. If you have taken screenshot, I will move towards next problem. Yes, Mansi, Mayur.
Yes, sir.
Karan. Okay, so we will solve next example. Okay, before that one example I will give for homework. So please draw figure. Simply supported beam is given. Okay, on that beam, 2 point load and 1 UDL is applied. Simple problem is there. Okay, here AD beam is given. On that 1 point load is act at B point. Intensity is 50 kilonewton. After that, uniformly distributed load is applied in between B to C and intensity is 20 kilonewton per meter. And at C point, 1 point load is applied, intensity is 30 kilonewton. This is for homework. Okay. Now we will take one example here. Only UDL is applied. That type of question we will solve here. So simply supported beam is given, and on that beam only uniformly distributed load is applied at certain portion or some portion. This is A point, this is D point, this is B, and this is C. Okay, span is 3 meter. Span for B to C is 2 meter, and span for C to D is 1 meter. And intensity of UDL is 30 kilonewton per meter. 30 kilonewton per meter. Okay, fast we will solve this problem. So you tell me, first step, reaction calculation. Reaction calculation. Okay. So here RA reaction is there at A point and RD reaction is there at D point. So in that first step is summation FV, which is equal to 0, upward forces positive, downward forces negative. So according to this, RA and RD going upward. So RA plus RD. This 30 going downward. So minus 30 into 2, which is equal to 0. So RA plus RD, which is equal to 60 kilonewton, equation 1. Then we will apply second equation, that is summation movement at A, which is equal to 0, clockwise positive, anti-clockwise negative. Okay, so this RD creates anti-clockwise movement. So minus RD into perpendicular distance 6 meter. After that, we will move toward this 30 kilonewton per meter force. This is creates clockwise 30 into 2. Then it will act 2 by 2 plus we have to add this 3 meter. Why? Because of it will act at its CG, but we are taking moment at A. So plus 3, which is equal to 0. We will shift this minus 6RD to right side. So 30 into 2 into 4. How much? 30 into 2 is 60. 240, no?
Yes,
Yes,
ma'am.
240, which is equal to 6 RB. So RB, which is RD, RD, which is equal to 240 divided by 6. So RD, which is equal to how much? RD, which is equal to
40.
40 kilonewton. Now we will substitute this value in equation 1. Okay. So put RD in equation 1. So RA plus RD, which is equal to 60. So RA plus 40, which is equal to 60. So RA, which is equal to
20.
RA, which is equal to 60 minus 40. So RA, which is equal to 20 kilonewton. We will calculate shear force. Second step is related to shear force calculation. SF calculations. SF calculations. So RA is 20 and RD is 40. Okay, so now you tell me shear force at A, which is equal to, we will write directly. Shear force at A, which is equal to upward force is there. So 20 kilonewton. After that, shear force at B. There is no any force in between A to B. So we will calculate at B. So shear force at B. Same because of here no force. So at B again 20 kilonewton. Now we will calculate shear force at C. Shear force at C, which is equal to, up to this B point force is 20. And in between B to C downward force. So minus 30 into 2. So shear force at C, which is equal to how much? Minus 40 kilonewton. Minus 40 kilonewton. After that, we will calculate shear force at D. Shear force at D. So shear force at D, which is equal to minus 40 plus 40, which is equal to 0 kilonewton. Now we will find out zero shear force location. You observe here at B shear force is positive and at C negative. So we have to find out the zero shear force location. Zero shear force location. Zero shear force location we will find from this B point at X. We will assume at X meter. So 20 minus 30 into X. So here we will consider suppose X. Okay. Which is equal to 0. So 20 which is equal to 30x. So X which is equal to 20 by 30. X which is equal to how much? X which is equal to 0.67 meter. But from this B point, suppose we have to find out from C point, then X which is equal to 2 minus 0.67. So X which is equal to how much? 1.33 meter from C point. Okay. So at this point, shear force is 0 and at that point bending moment is maximum. We will do calculations here for bending moment. Next step is step number 3, bending moment calculations. Bending moment calculations. So bending moment at D, we will start from this D. Bending moment at D which is equal to 0 because of force is there but perpendicular distance is not there. we will calculate at C point. So bending moment at C, which is equal to, so here 40, and at up to this C point 1 meter span is there, so which is equal to 40 into 1, that is 40 kilonewton meter. After that we will calculate maximum bending moment. Maximum bending moment, which is equal to, span is likewise here 40, okay, at here C point is there, and after that here this is X, so up to this 1 meter, and from C point distance is 1.33, here C point is there. So 40 into how much? 40 into 2.33, which is equal to how much? Yes, 90.
3.2.
But we have to consider here UDL also, na? Okay, maximum bending moment, which is equal to, this is 40. Okay, suppose this is C point. Okay, so from C to X distance, UDL is there, na? This distance is 1.33, and this is 1, and here UDL is 30. Now we will calculate. So 40 into 2.33 minus 30 into 1.33 into 1.33 by 2. So you calculate and tell me maximum bending moment, which is equal to how much? .67 kilonewton meter. Now we will calculate bending moment at B. Bending moment at B, which is equal to, we will calculate from this left side because of there is no force. Suppose this is B point and here A point, this is 20 and span is 3. So which is equal to 20 into 3, which is equal to 60 kilonewton meter. Okay. And last, bending moment at A, which is equal to 0 kilonewton meter. Last step, we will draw shear force and bending moment diagram. SFD and BFD. This is A point, B, C, and D. 3 meter, 2 meter, and 1 meter. RA is 20 and RD is 40. So first we will draw shear force diagram. Then we will move towards bending moment diagram. So I think shear force values are plus minus. Okay. So diagram will be above and below baseline. So shear force at A, 20. Okay. In between A to B, there is no any force. That means shear force is constant in between A to B. Okay. After that, shear force at C. How much shear force is there? Minus
40.
minus 40. So it will go below baseline. Okay. After that, there is no any force in between C to D. So diagram is constant. And at D, shear force is 0. Okay, this is positive, this is negative. Here A point, here T point. This is 20, here also 20. At this point, shear force is 0. Here value is 40. Here also 40. And here 0. This is the shear force diagram. Now we will draw bending moment diagram here. First we will mark values and then we will draw. I think all values are positive. Suppose our baseline bending moment at B 0. Sorry, bending moment at D is 0. At D 0. At C 40. Okay. I will extend this line 0 shear force line. So maximum bending moment is 66.67. After that, bending moment at B. Bending moment at B is 60. So near about this 60. And bending moment at A is 0. Now you tell me where only parabolic connection is there. So B to C. So up to this point. And here connection is linear. Okay, so this is the bending moment diagram. Whole diagram is in positive. This is bending moment diagram. This is A point. This is D point. Okay, please write down fast or you take screenshot. Okay, please take screenshot fast. So I will close the meeting. Okay, so today we will stop here. In next lecture, we will continue cantilever beam and overhanging beam. Okay, thank you for attending lecture. Thank you.